Alright, so here's our video that we're going to use to be able to complete the equation of the regression line. So I'm going to kind of put some on you and that you'll have to piece this together. This is kind of one of the beginning questions in section 10.2, and then you'll have to take your knowledge from 10.1 and then the knowledge from this video to be able to complete the latter questions. And keep in mind that when you're working those problems inside of homework for 10.2, if you do it once, you might need to come back another time and try that problem again or try another one. So just keep that in mind, and so that way you got the practice down and you're ready to go for the quizzes. Or the quiz, excuse me. So, alright, so first question, just like always, we need to determine whether or not we should even do this. So, in our steps, we said that we could create a scatter plot. But it's just as effective with technology and with everything else. And in this situation, we're looking at the concept behind this. So the concept, how do we determine whether it would be good to do this? Well, step 2 of it is to go ahead and compute the regression, the correlation coefficient, and then compare that and see whether or not we would fall in. So remember, table I basically allows us to take a correlation, and so our correlation is R equals 0.972. It allows us to say that we have a sample size of 1, 2, 3, 4, 5, 6, 7. Therefore, our degrees of freedom is equal to n minus 2, or 7 minus 2, which is equal to 5. So we can come to our chart. We can come across at a degrees of freedom of 5. We have an alpha or significance level of 0.05. So that essentially means that our critical value is going to be at 0.754. Now, at that point, if you go back and remember your curve that we had, and we're trying to establish our non-critical and our critical regions, remember this would be our critical region. And so our cutoffs here that created by our critical value would be 0.754, negative, and positive 0.754. So then this correlation value that they've given us, see, table I already does all the conversion for us, and so it's kind of real handy. We don't actually have to do the test value. And so in this case here, we know that we're looking at 0.972 as, I guess, like our test value, or in this case our correlation coefficient. So we know that we're in that critical region, so we know that we should go ahead and go forward with our regression analysis, because we're going to find out that there is some type of significant relationship. Alright, so from there we go on to step 2. So step 2 of finding the equation is that we need to actually calculate that A value and B value that we saw in the first video. So remember, I told you that we'd either be doing this with easycalculation.com or with my graphing calculator. So the website is linked up here in the top corner. Let me slide that down so you can see it better. So little icon's not in the way. But just keep in mind that this is also linked inside of the assignment, and so you can reference it there. Go to easycalculation.com and type in regression equation, and it'll pull it right up. Alright, so here we go. Let's pull that up. Alright, so same concept, same idea. Let me shrink my screen a little bit so I can see things a little bit better. Is that, we're basically going to enter in our data values. So we'd start off here and we'd type in our 62, go over to our y, and it's 62. And then we would add more. And we'd type in 69, tab 64. And we would continue through the list. I'm going to hit pause, put my numbers in. Okay, so I got my numbers put in. I can see I had 7 numbers total, which matches up with our data set. I hit calculate, and it kicked out my B value, my A value, and look, at even put my stuff into the regression equation for y prime. So we go on back to the presentation. So at this point, we can see that right from this, we can go ahead and interject and type in our A value. Remember, we want to round it to 3 decimal places, and type in our B value and 3 decimal places, and you're ready to go. Okay, so next piece, let's keep in mind this equation. I'm going to bring that equation with me. So for the next thing, we want to make a prediction. So we want to be able, the whole idea here is that hey, we collected this data that represents the population, and so inside the parameters of this population, I want to make a prediction. So my parameters here is essentially I've got a number of fires between 47 and 84. So that's kind of like my range. So I want to make a prediction. Well, what would happen if I had 70 fires? How many acres would I burn? So this is that concept of kind of keeping yourself inside the parameters of your data instead of trying to reach outside. None of our data here has collected information for what would happen if we had 100 fires. So it's not going to be as accurate to make a prediction with 100 because it doesn't fall within our data set. So let's make a prediction with what we had. So bring our equation across. So remember we had this guy right here. And so we see that we have this equation of y prime is equal to negative 3.31 plus 1.029x. Well, our x value we wish to insert is a 70. So we say y prime is equal to negative 3.31 plus 1.029 times 70. I'm going to hit pause, grab my calculator. So negative 3.31 plus 1.029 times 70. And we find out that our prediction at that point would be that we would burn 68.72 acres. Alright, so that's how we can create a linear regression equation and then use that regression equation to make a prediction.